Hello my dear students, so I welcome you all to the lecture series of mechanical properties of solids. This is the lecture number 2. In the previous lecture, we have learned about deforming force, restoring force, intermolecular force, then elasticity, cause of elasticity, potential energy versus distance graph, then force versus intermolecular force versus distance graph. Okay, and this was the introductory lecture to understand the meaning of elasticity. Okay, and this is what basically we have to learn in this chapter. The main topics of this chapter are here: types of forces, based on that stress and their types, then strain and types, Hooke's law, modulus of elasticity and their types. Okay, so this much I will try to cover. Additional topics are there, so if possible I will cover in this lecture or in other lecture. So along with this we have to solve some numericals also. So if possible in this lecture, or I will create a separate lectures based for the numerical part. Is that clear? So if you have watched my lecture number 1 based on this topic, you go to the description box. I will provide the link for that video. If you don't want to watch that, no problem. In this, while discussion of these topics, this also come in picture. Okay, so no problem in that. So you will understand everything, right? So let us start now. Ready? Right. So let us start. Deforming force, the force which want or tends to change the shape and size of the body. Okay, this force acts on the body. This is the external force, acts on the body and want to change the shape and size of the body. Okay, that is called deforming force. What are the types? One is direct or normal force. Another is shear or tangential force. Two names are there. Shear means tangential. Direct means normal, one and same. Which is the normal force? The force which is perpendicular to the surface. Perpendicular to the surface, like this. Like this it should act. Like this or like this. Or like this, no problem. But it should be perpendicular to the surface. If it is inclined, we have to resolve in two directions. 1 and 1, 2. The parallel force or tangential force. Perpendicular force is called direct or normal force. Okay. Now, this direct force, normal force have two types. Tensile, compressive. What is a tensile force? It is a pulling kind of force. Pulling kind of force. It's called what? Tensile force. Compressive, this kind of force. It will try to reduce the dimension. It will try to increase the dimension. Okay, so this is the basic types of forces. Based on that, we have to see the type of stresses. If it is inclined force is acting, then what we have to do? We have to resolve this in two directions. Suppose this is the theta. So this will be what? F cos theta. This will be F cos theta and this will be F sin theta. So F sin theta will act parallel to the surface and F cos theta will act perpendicular to the surface. So this is what? F cos theta. This component is comes under direct normal force, and this is a shear force. Got it? It should be parallel. Shearing. We call it shearing, no? Like this. Shearing we call it. Okay? So note it fast. Come on. Pause the video and note. Okay. Now look here. Stress. What is stress? Stress is what? The internal resistance. What? Internal resistance, that is a restoring force per unit area is called stress. Right? It is denoted by sigma. Sigma. It is denoted by sigma. Like this you can write. Force upon area. Sigma is equal to force by area. SI unit Newton per meter square. Force Newton. Area meter square. Okay. Its dimension you can write if you want. Other units of CGS unit. Dyne per centimeter square. CGS unit. Then other units are also there. 1 Newton per meter square is called Pascal. Okay, PA. Other units are there, but mostly those units we use for pressure. Pressure also what? Pressure also force by area, no? So this in detail we will learn in mechanical properties of fluid. At that time other units are also there that we will see. But for stress mostly this Newton per meter square, Dyne per centimeter square, Pascal sometimes, or Newton per millimeter square. This is also used, right? So we will see that while solving numericals, these units and all again we will come across with that. Now look, this is all there, but what is exactly stress is that we must understand. So what is that? Look, suppose this is one body, okay, and on that some force is acting. Let us say compressive force is applied. Compressive force is applied on this body. What will happen? Body, intermolecular force of attraction we have learned. What happens in the atomic level or molecular level? If force is applied, their natural distance between them will be disturbed. They will come closer, which they don't want. What will they do? They will apply a repulsive intermolecular force. Okay, that repulsive molecule means there is an opposition, resistance to the external force. Yes or no? They are opposing the external force or not? Tell me. So this is a resistance offered by the body. Resistance offered by the body to the external force. Because what? They don't want to change their original distance between them. That is called inertia. Okay. So, and after removal of force, they will regain that shape. That is called elasticity. Correct or not? So, that is the internal resistance. And that force, we call it as a restoring force. After removal of force, due to this force only, body regains its original shape and size. No. They will maintain intermolecular distance between them. Correct or not? Understand this. So, stress is the internal parameter. Stress is the internal parameter. Okay. Internal force divided by, this is what? Internal force. Internal restoring force. This is the internal restoring force. Okay. Or internal resistance we say. And this area, cross-sectional area. Suppose this area should be perpendicular to this. Okay. Sometimes parallel also. Right? So, this is what? Your stress. Basically what? So, if somebody asks you, what is the stress? So, simply don't say stress is the force by area. No. What is that force? That force is basically internal resistance, internal restoring force. Now, how to calculate the force then? How to calculate the stress then? Force. This is the restoring force divided by area. What is this restoring force? Look, that restoring force, suppose on this body, this force is acting. This is what? External force. This is what? External force. Barabar? Correct or not? So, body will oppose this force like this. This is coming like this, this is coming like this. If tensile is there, then this kind of force will be there. If compressive force, external force is compressive, then this kind of force will be there. So here we have taken compressive force. So internal resistance is like this. And this force, this internal force is equal and opposite in direction. This FR, internal resistance, is equal to what? External force. Magnitude, same. Direction, opposite. Remember this. Internal resistance is always in the opposite direction of the external force. And magnitude is same. If you increase this external force, then internal force also increases. Body have that value, that tendency. Okay, extra force you apply, it will increase its opposition. Okay, and that is equal to this. So, mathematically, this FR is external force which we apply. That by divided by area, that's okay. Mathematically same it will come. These two forces are same. But conceptually, this force is the internal resistance. So force becomes, this stress becomes internal parameter, not external parameter. pressure becomes the external parameter. That we'll see in the solid, in the fluid. Got it or not? Right? Now one simple question I want to ask. One simple question I want to ask. Note this. Now, one simple question I want to ask is that, suppose this is one surface. What? This is one surface. And here, this is one body. This is a smooth surface. Smooth surface. Okay? And I am applying this force. Correct? Force is applied on the body. Right? Cross section area is A, मान लो. Okay? Cross section area is this something. Here, this is the area. Right? This is the body. Kept on the surface. On this table, this body is kept. This is the area. A something. Value we know. This force we know. Now, what is the value of stress here? Tell me. 0. Stress will be 0. Why? Sir, there is a force. There is an area. So why not F by A? Why not F by A? Stress is there and I am saying 0. Because stress is not external force by area. Stress is the internal force by area, and here there is no internal resistance. Why? Because if you apply this force, body will move. It will not oppose. It will not oppose. It will not change any intermolecular distance. This force will not change any intermolecular distance. Correct or not? But if I will apply, if I suppose if there is a wall on this side, and if I am applying this force, what will happen? This wall will exert normal reaction equal to this force. Means such a kind of case is there. Now body will not move and force is acting on both sides. What will happen? Intermolecular distance decreases. So body will try to increase it. Now internal resistance develops. Intermolecular force will increase. Repulsive intermolecular force will increase here. That is internal resistance. And if internal resistance is there, opposition is there, only then stress will come in picture. And that internal resistance is equal to the external force. Then we can apply this formula. So stress will be there, force divided by area, then no problem. So restrictions to the motion should be there. Otherwise, there is no stress. External force will be there. So it will carry the body somewhere. Motion will be there. Clear or not? There must be some restriction to the motion, constrained motion we can say. Right? If it is body is free to move, ready to get displaced, and there is no opportunity, no friction, nothing is there. Only this force is there. External force is there. What will happen? There is no question of internal resistance. But such a kind of force on the opposite side will be there, then yes, there will be the internal resistance. Otherwise, there is no stress. Let's understand this by a day-to-day life example. You want to go to watch a movie, your friends are going, okay, and you ask your parents, there is this Saturday night evening and tomorrow there is an exam, weekend test is there, and your friends are going, you want to go, your study is completed, you are having confidence, and you want to get fresh up, and tomorrow morning you want to revise and you want to face the exam. So you are confident, but you ask your parents, then you will say no, you should not go. Tomorrow there is exam, after the exam you go. That also we will see based on your performance. No, go there, go to your room and study. What will happen? Your motion is restricted now. So when your parents allows you, then there will not be any stress in your mind. You are free. But so if your parents don't allow for that, then what will happen? You will be nervous. So that nervousness we will treat as a stress in your mind. Correct or not? But if your parents say, oh, where you want to go? For watching movie? Which is that? Where is it? Okay. Or have you completed your study? Yes, father, I have completed my study. Okay, no problem, then go. Take the money from my pocket. Whatever you want. Okay, so you will be happy. Let us go to the movie, watch the movie, enjoy with the friends, eat popcorns, eat samosas and all. Okay, na? So you will be happy, stress free. So you are allowed to go. Then there is no stress, there is no tension, there is no nervousness. But if they will restrict you, your motion is restricted, then stress will be there. You will be happy, you will be nervous. Correct or not? So this is the stress. If motion is constrained, body is not allowed to move, then this force will try to compress it or elongate it. Intermolecular distance will change. Restoring force will be developed. Body will oppose that, and stress restoring reforming force will be there. So resistance will be there, and all things will happen, and stress will come in picture. So that is a force by A. Otherwise, no stress. Remember this, very important. Clear? You understood the meaning of stress now? Now, we will see the type of stress based on what? Forces, which we have learned just now. Okay, so note it. So, okay, types of stress. What? Type of stress. Types of stress. Type of stress now. What are the types of stress? First one, direct normal stress. Okay, what is this normal stress? Sigma stress force by area. Here, direct force by area. Direct force is what? Perpendicular force. Just now we have learned. Okay, so perpendicular force to the area. So this force is perpendicular to this area only. Then this is called what? Direct or normal stress. In that, two types. If force is tensile force, perpendicular to the surfaces, cross section, then this is the formula. Formula will be same, no problem in that. Force by area, that is the stress. But which force we have to take? This force here. So compressive like this. Okay? Then shear stress or tangential stress. It is denoted by tau. Parallel force divided by area. So like this force will be there. Such a kind of force will be there. So this force and this area, which is parallel to that surface. Here, what is the angle between this area? Surface and force, angle is 0. And here surface and force, angle is 90 degree. That you must understand. Depending upon that, two types are there. Or three types are there, we can say. Then, so third type, volume stress. First direct stress, then shear stress and volume stress. So what happens basically, suppose this is a liquid. This is a liquid, and in that one sphere is kept, or any body, spherical body is there. What will happen? So there will be the force acting in all direction on this. Force will act in all direction. So what will happen? Due to this shape will be, this diameter will decrease. Okay, so this is the new shape. So due to that, what is happening? Change in the volume is there. Correct or not? So and this body will oppose. You don't want to change its shape now. So that internal force will be developed. So that volume that will generate a volume stress. So this volume stress is equal to force by area. Same, but which force? This force we have to take. Internal resistance will be there, no. So at this point, this is the external force, and here this force will be there. For this will be there. This force will be there. This force will be there. This force will, at every point, this will be there. So total forces divided by total area, that will be the what? Volume stress. Okay. So this volume stress is basically a pressure. Is basically a pressure. That this we call it as a pressure or change in pressure. Basically change in pressure. Change in pressure. Because this body is kept there, some pressure will be there, and due to that additional force is there, so additional pressure will be developed. So basically this volumetric stress is equal to change in pressure we can take. Strain. It is denoted by E or sigma, epsilon or E. Okay. What is strain? Strain is basically change in dimension divided by original dimension. What? Original dimension. Strain is equal to change in dimension by original dimension. Okay, no problem. So suppose here this is a length, and due to this tensile force, what will happen? After some time this length will increase. Okay, so let us take on one side, we will fix here and we will apply this force. Okay, so basically two forces are acting on both sides, this force and here this force. Normal reaction will be there. Okay, so body will apply normal reaction on this side, so wall will apply normal reaction on this side. So like this will be there. So on the body, one force on this side, one force on this side, equal and opposite force will be there. So due to that, what will happen? But increase in length we can show on this side only. Otherwise I have to show increase in length on both sides. I have to show if this kind of force, if I will show, and if I will say this is a fixed here, then I can show same situation will be there in this also, but I can show the change on this side. That is why I am taking this type of diagram. I am using this type of diagram. Okay. So due to this force, what will happen? This length will be there. This is a new length. L dash, new. So what is the change in length? New length minus original length. New length, this new length minus this original length. So this is a change in length. Okay. Now, what is the strain then? Strain is equal to change in length delta L divided by original length. Original length is L. So this is what your this strain. Now look here. What about units? This is also measured in meter, SI unit. This is also measured in meter. Meter cancel. No unit. This is a unitless. What? Unitless. Even dimensionless. Dimensionless, unitless. Okay. Right. Understood? Simple. Change in dimension by original dimension. Okay. Now, based on the forces, just like we have seen the types of stress, we will see the type of strain. Okay. So let's start. Strain. Type of strain. Okay. Now, type of strain. Ready? Okay. Direct strain or normal strain. Direct strain or normal strain. So direct strain, normal strain means what? Force acting on the body is what? Change occurs due to what type of force? Direct force. Direct force is perpendicular. Such a kind of case. Tensile or compressive, whatever it may be. But it should be normal force. Normal force, direct force means what? Perpendicular to the surface. In this case, whatever change in the length, change in the dimension. It may be length, it may be breadth, it may be diameter, anything. That is what? Matlab what? Delta D by D. Change in dimension, diameter is happening. Sometimes what will happen? Change in thickness will be there. So no problem. Delta T by T. Whatever it may be. Change in dimension is happening. Then that change divided by original dimension is called what? Stress. So force is perpendicular, then normal stress or direct stress. Clear? Simple? In the same way, shear strain, tangential strain. What will happen here? Suppose these are the books I will keep here. This is one book, this is another book, third book, fourth book, like this. What will happen? Why I am saying book? Because in material also such a layers are there. Your notebook is there. One page, another page, third page, fourth page, like that is there. In the body also such a layers are there. In a fluid also such a layers are there. So if parallel force is applied on this side, shearing force, what will happen? So it will apply more force on the top layer, and due to that what will happen? So such a shape will be obtained. Such a shape will be obtained. So this will move. So this is, let us say this angle is phi, and this distance is what? X. Okay, and this length is, let us say, d. This height is d. Okay, now how much is the displacement? Maximum displacement x. Okay, so this distance divided by this distance, we can say it as a shear stress. Shear stress. It is denoted by phi, or simply this, we can say this x divided by this length is. So this much is distance, change in the displacement or a change in the top layer, and total height. So this will give you what? Stress. Now x by d means what? X by d means what? This is the hypotenuse, we can say. This is 90 degree. Opposite by adjacent means what? Tan theta. Phi you are saying, na? So tan phi. Or if you are taking theta, tan theta, that's it. So this is what your shear strain. Are you getting? Simple. If parallel force is applied, there are layers. So layers will be disturbed like this. Then what is the mathematics to calculate this? X by d, or mathematically we can say this is a tan phi. This is what your tangential or shear strain. Only important is what? Force should be parallel to the surface. That's it. Right? Then volume stress. Let us talk about volume stress. Note this first. Come on, pause the video and note. Volume stress. Third one is what? Volume stress. All stress, whatever may be the type, unit is no unit. It's unitless. Strain. Okay, no problem. Before volume strain, I want to tell you some two types in this. One is longitudinal, and another is lateral. Another is lateral strain. In both, we have what? Force is perpendicular to the surface. So strain will be direct or normal, not shearing. I am not talking about shearing. I am talking about this only. But in that also two types, longitudinal and lateral. What is this? So look, suppose if this is a rod, I am applying tensile force on this. So force is perpendicular to the surface. So whatever change in the length will happen, delta L by L will be the strain. Change in length divided by L. So this dimension, length, is along the applied force. This dimension is along the applied force. Then change in that dimension divided by original dimension, that will called as a longitudinal stress. This is what? Longitudinal. This is a longitudinal stress. Strain. This is a longitudinal strain. Remember. Which is the longitudinal? So length, we can here, length we have to consider that dimension which is along the force. And due to this, volume is constant, this stretching is happening, length is increasing, there will be the change in the diameter. Diameter will reduce. If length is increasing, diameter will reduce. Okay, so change in the dimension. Change in the dimension along that direction means diameter, change in diameter. Change in diameter divided by original diameter. So this is called what? Lateral. This is called what? Lateral strain. Do you understand? Do you understand? Change in diameter due to same force. Due to same force, these two changes are happening. One, length is increasing, diameter is decreasing. So change in length by original length, longitudinal strain. And change in the diameter by original diameter is a lateral strain. So what is the lateral dimension? Force is perpendicular to the direction. Diameter we measure like this. So force is perpendicular to this. Then this dimension is called lateral. Force along this dimension, this is the length. Suppose on this rod I will apply this kind of force. What will happen? this kind of force in all direction, what will happen? This diameter will reduce, so length will increase. Then in that case, suppose if I will apply this kind of force, what will happen? Diameter is going to reduce, so length is increasing. So here longitudinal strain will be what? Delta d by d will be the longitudinal, understand? Because the length or dimension along the force is a diameter, and that we have to consider as a length, and that will give you longitudinal strain delta d by d. And the length will be, this is the length will be perpendicular, so length we have to consider as a lateral dimension. So lateral strain will be what? Change in length, lateral will be what? Change in length by original length will be the lateral strain here in this case, and this is a longitudinal. In this case, change in length by original length is a longitudinal strain, change in diameter by this is a lateral strain. We can have many other dimensions also. For example, this. Here, this is the width, this is the thickness, and this is the length. Correct or not? So force applied like this. So length, change in length by original length will be the what? Longitudinal strain. And due to that, what will happen? Thickness will decrease, this width also decreases. These two dimensions are decreasing. So delta t by t, lateral strain, delta w by original w, lateral strain, and this is the longitudinal. If you will apply, instead of this, if you will apply this type of force, what will happen? This dimension means thickness will become longitudinal. Change in thickness divided by original thickness will be the longitudinal strain, and change in the length, and this will be what? Lateral. Okay. So lateral strain, another important thing. So if the length is decreasing, any dimension is decreasing, so that strain we have to consider negative. If dimension is increasing, then we have to consider as a positive. So in such a cases, what we have to understand? Look, here length is increasing, so this will be positive, so this will be negative. And if in this case what is happening? Diameter is decreasing, so this will be negative, and this will be positive. Length is increasing. Depends upon the force. Compressive force, dimension along that will be decreased, other dimension will increase. So that will be positive, this will be negative. Vice versa. If tensile force is there, the dimension along that tensile force will increase, other lateral dimension will decrease, so that will be negative. So like this. Only what you have to remember? If change is positive, matlab increase in the dimension is there, that strain is positive. If change is negative, that is decreasing, then that strain will be negative. That's it. Got it? Understood the type of this direct stress? Shear stress we have learned. Now let us come to volume stress. Okay? So what is this volume stress? Pause and note. As I told you, suppose in the liquid, this body is there, so force will act on this direction. So due to that, what will happen? This will be the same. So this is the change is happening. Barabar. So volume, original volume. So change in volume is what? Final volume minus initial volume. Okay. Now strain will be what? Change in volume divided by initial volume. And this is mostly what? Negative. This is mostly what? Negative. Got it? So this is a volumetric strain. Simply volume strain. Change in volume by original volume is a volume strain. Understood? So this mostly we will discuss in the fluids, properties of fluids. Time being, you can use this formula. So these are the types of stress. Now let us talk about relation between stress and strain. Whenever force is applied, stress will be developed and change in dimension occurs. So what is the relation between all these parameters? That we are going to discuss. So next is a Hooke's law. So let us start that. So what is the relationship between stress and strain? Okay, so Hooke's law will give you the relation between stress and stress. What Hooke's law says? It states that with the for a small deformation, the stress is directly proportional to strain within proportional limit within a proportional limit. Okay, so this stress is directly proportional to strain. Stress is equal to E. So what is this? I want to remove this proportionality sign, I want equality sign, so I want a constant of proportionality. So here this E is called constant of proportionality in Hooke's law, and also called what? Modulus of elasticity. Also called modulus of elasticity. Remember, also called modulus of elasticity. Right? No problem? So now understand, for small deformation, okay, deformation is very small, in that only. Otherwise what will happen, if more deformation is there, plastic region will come and body will get permanent deformation. At that time this Hooke's law will not be applied. So that we will see in the stress strain curve. Time being, just to understand, for very small deformation some force is applied and some little change in the body occurred. At that time the stress is directly proportional to strain. There is a limit, proportional limit. Okay. So matlab means what? Up to certain level of force. Okay. So this will happen. If force is more, then it means what? Body have some capacity, no? Body have some capacity to resist the body. Otherwise what will happen? If more and more force you are going to apply, bodies don't have that capacity to resist. So there is one limit. Okay. So that is the proportional limit. So in detail we have to learn, that is the elastic limit, basically later on we will see. So first of all let's complete this. Stress is directly proportional to strain, and here constant of proportionality we have taken, and this is called what? Modulus of elasticity. Right? So from this we can write this E is equal to stress by strain. What is the modulus of elasticity? Stress by strain. Right? Stress, unit of stress, Newton per meter square, divided by strain, no unit, unitless. So overall, what is the unit? Newton per meter square. So unit of stress and modulus of elasticity is same. Remember, unit of stress and modulus of elasticity is same because this is unitless. Right? Understood? Now, so if you draw the graph of this stress versus strain, so this will be a straight line because they are directly proportional to each other. Okay, straight line you will get, right? And for small deformation only, means this strain value will be small. If more is there, then no. So this is what your proportional limit. Up to this point only. Later on things will change. Okay, so that we will discuss in detail later on. Time being, this much. Now here if you talk about slope theta, so tan theta will be slope. So what is this then? stress by strain. Yes or no? Y2 minus Y1, sigma 2 minus sigma 1 divided by sigma 2 minus sigma 1. This point you will take, this point you can take, any 2 point you consider. This is sigma 2 and this is the sigma 1. So y2 minus y1 divided by what? Divided by this is sigma 2 epsilon 2 epsilon 1. So epsilon 2 minus epsilon 1 or E2 minus E1. What is this then? So delta stress, change in stress, change in this we can say. So basically what is that? Stress by strain, and stress by strain is what? Modulus of elasticity. So slope of stress strain graph gives modulus of elasticity. That's it. Tan theta is equal to modulus of elasticity. Clear? Simple? So all theory is going on. When we solve questions, then you will get more interest. But basic things we have to understand first. No, that's why. Okay. So note it fast. Let's finish fast. Then we will see types of modulus of elasticity. And after that, we will see we can solve numericals. Okay. So let us start this modulus of elasticity. Note this first. Types of modulus of elasticity we are going to. So types of modulus of elasticity or elastic modulus. Number 1, Young's modulus. Number 1, Young's modulus. What is this Young's modulus? Young's modulus, in this, it is mostly, it occurs in solids. So Young's modulus is equal to what? So this is basically modulus of elasticity, means stress by strain, no problem. Everything is same, unit same, formula same, everything same. Only care we have to take is what? This force, this is what? Here, direct stress is there. This is what? Here, what you have to remember is, this is what? Direct or normal. This is the direct or normal stress. And this is what also? Direct or normal strain. Then we can say this modulus of elasticity. See, basically is what? Modulus of elasticity is what? Stress by strain. So this type are there. For stress there are sometimes, strain there are sometimes. If direct stress is there divided by direct strain is there, then it becomes modulus of elasticity. It becomes Young's modulus. We will call it as Young's modulus. Okay, and this we will use mostly in solid. We will talk about this mostly in solids. Right? Simple? Everything is same. If direct force is there, here force is perpendicular to the surface, then we will talk about this. Right? Second is what? Shear modulus. Shear modulus. What is shear modulus? Any notation we can use. Eta, let's take. So this will be same. Stress divided by strain. But which stress? Which stress? Shear stress, no? Shear stress. And shear stress is what? Parallel force divided by area. And this is what? Tan phi. We have seen. So like this we can say. If this theta, this is what happens now. This force is applied. Change in this. So if this theta is very small, if phi is very small, then tan phi is equal to phi we can write. So finally eta is equal to what? Parallel force divided by A into phi. Okay, so mostly there are no questions on this, but it is there in the syllabus, so we can use like this. Okay, shear stress by shear strain is what? Shear modulus. Direct stress by direct strain, Young's modulus. Solids, this is also occurs in mostly in solids and in fluids also. Okay, so in fluid mechanics we will see this. Right? Now third one, bulk modulus. So note down this. We will see the third type. First, bulk modulus. Come on, note. Okay, pause and note. Bulk modulus. Third one, bulk modulus. What is bulk modulus? Bulk modulus, stress by strain. Which stress? Volume stress here. Third type of stress, volume stress. Then divided by volume strain. This type we have seen now. Third type. So B is equal to what then? Volume stress. Volume stress we have seen. Change in pressure. Change in pressure divided by volume strain is what? Sigma V divided by sigma V. Volume stress by volume strain. Delta P, I told you, change in pressure divided by this delta V by V. But mostly this is the negative, volume is decreasing. This will talk or discuss mostly in liquids, fluids, right? So finally we can write this as a minus delta P divided by delta V by. So this is what your bulk modulus. This is what your bulk modulus, right? So another word is there, compressibility. So we will not talk more about this. Compressibility C is the reciprocal of bulk modulus. Compressibility is what? Compressibility is the ability of the material to get compressed. See, what is the compressibility? The ability of the fluid, basically fluid, to get compressed is called compressibility, and which is given by 1 by B. B is what, or beta is what? Bulk modulus. Bulk modulus is what? Volume stress, that is the change in pressure divided by change in volume. Volumetric strain, change in volume by volume. Okay, so this you just note. So mostly in this chapter we will talk about, or we will solve questions mostly based on Young's modulus. Mostly 90%. Remaining are there. Some questions are there. We will take and we will solve later. So length of the video is more. So I think for numerical part I have to record another video. So subscribe my channel, press on the bell icon, share this video to others, and in the next lecture again we will meet, and there we will solve lot many questions based on all the parameters which you have learned. So today we have discussed major portion, theoretical portion of this chapter. Additional things are there, stress strain curve, potential energy, so and then other elastic constant, Poisson's ratio and all that is there. So that we will discuss in the last lecture. Before that I want to solve some numerical. I want to give you exposure how to solve the questions based on this Young's modulus, based on this strain and all that. Okay, so that will be the more important lecture for you. So within 2 days I will record that. So this lecture you watch it fast. Okay, once you watch, so that to revise the things and come for the next lecture. Thank you.